I was muted that whole time. Oh, of course I was. All right, backing it up. Apologies to anyone who was watching me be silent. Okay, starting again. Here we go. Actually, oh no, I don't want to go back. I want to go to courses. Learn object-oriented programming. But let's jump back to what is object. Chapter 1 classes. Eli T. Drum, thank you for stopping by. And thank you for the forgiveness. I appreciate that. Hey, I saw on Twitter that you had posted that you got a VOD on Twitch. I should go listen. I should go listen to that. I'll be interested to hear what you had said there. Okay. Well, that was a spooky lack of audio. I hope you all survived and didn't get too scared of that. Starting over. What is object-oriented programming? Object-oriented programming, or OOP for short, is a way of writing code that relies on the concepts of classes and objects. The main benefit of writing your code in an object-oriented way is to structure your program into simple, reusable pieces of code. In this course, we'll be coding the pieces of a real-time strategy game called Age of Dragons. Players will control armies of men, elves, orcs, and dragons as they fight with one another online. If you're familiar with Age of Empires, Warcraft, or Starcraft, it will be something like that. Eli says, I forgot to record it actually. I fixed it so next time it'll be recorded. Oh, okay. Well, next time, better luck. Okay, we're on to the assignment. Assignment. Your manager has noticed that there is a ton of duplicated code in the project. She has tasked you with reworking the fight soldiers function so that the DPS, damage per second calculation logic, is only written once. Notice how these two lines are practically identical. We have soldier 1 DPS equals soldier 1 damage times soldier 1 attacks per second, and soldier 2 DPS equals soldier 2 damage times soldier 2 attacks per second. It's very clear from the scrolly bar that these are totally similar and the same. Wait a second, I need to reset the code. We can see over here it's the same code now that I reset it. The instruction is finish the get soldier DPS function and use it in the fight soldiers function. So what we're going to do here is we're going to return the result of a calculation, and that calculation is going to be soldier key of damage times soldier key of, what's the key name? Attacks per second. Let's run that and make sure it looks reasonable. I don't know if I read this paragraph yet, so let's go ahead and do that. Get soldier DPS should take a soldier, which is a dictionary, and return its DPS. It's the same logic that currently exists in fight soldiers, but now we'll only need to write it in a single place. So now that I've defined the function, I get soldier DPS as a function of soldier 1, and I get soldier DPS as a function of soldier 2. Check that that runs okay. All right, got it. Moving forward. Let me put on my timer. Clean code. Object-oriented programming and other paradigms like functional programming are all about making code easier to work with and understand. We call code that is easy to work with clean code. Martin Fowler says, any fool can write code that a computer can understand. Good programmers write code that humans can understand. So the point is that code needs to be read by humans because humans may need to come along and change it or understand it or add to it or any number of things. And it's not enough just that the computer knows how to run it. Clean code is not a way to make your programs run faster. It's not a way to make your program use less memory. It's not necessary to create certain kinds of programs. And it's not strictly better than non-OOP code. I'm going to take a screen cap of that, except I already took a screen cap of that. But anyway. Clean code is designed to make code easier to work with in many situations, something that helps humans model and simulate the real world, a way to make finding and fixing bugs easier, a way to make new feature development faster, and the best way to stay sane as a software engineer. That last line is a bold claim, and some might disagree, but for now I'm going to take the editorial stance of the course and say that yes, clean code is a good way to stay sane. Clean code, does it make your program more efficient? Not necessarily. Is it the only way to write working code? Certainly not. Does it make the game you're developing more fun? Doesn't have to. Is it easier to work with as a developer? Yes, it is. And I already answered that one. Okay, we have a restatement of that. The primary goal of OOP, is it to write faster code? Is it to store less data? Is it to objectify people? Or is it to write cleaner code? That's the one. Dry code. Take a look at the code we wrote. We started with this, Soldier 1 DPS and Soldier 2 DPS. Soldier 1 damage times Soldier 1 attack per second. Soldier 2 damage times Soldier 2 attacks per second. And we refactored the code to look like this in 2 sections. Def get soldier DPS of soldier, return soldier damage times soldier attacks per second. So we have the details of the calculation written once in the function. And then we call the function get soldier DPS on soldier 1 and get soldier DPS on soldier 2. The principle is don't repeat yourself, or DRY. We don't want too much of our code doing the exact same thing. When code is duplicated, it leads to many potential problems. In our example, let's pretend the soldier dictionary changed, and now that the key that stores the damage value is called DMG. In the first example, we would need to update 2 lines of code. In the second example, we only need to make the change in 1 place. And I know you may be thinking, 2 places to change code, that's not a big deal. But the course is going to address that concern, saying it's not a big deal when 2 lines are the same and exist right next to each other. However, imagine if we had done this hundreds of times in 10 or 20 different code files. All of a sudden, it makes a lot more sense to stop repeating yourself and write more reusable functions. We call that dry code. Dry, again, for don't repeat yourself. Dry stands for don't repeat yourself. Dry code does not make your code shorter and easier to read. Well, not repeating yourself should make it shorter and easier to read. Does it not mean your code will be in the cloud? That doesn't make any sense. Does it not make your code easier to update? Well, it does make code easier to update. Does it not make fixing bugs faster? You only fix them in 1 place. I'm getting lost in the double negatives, but code in the cloud is orthogonal to whether or not you have dry code. So that's the one that it's not. Classes. A class is a special type of value in an object-oriented programming language like Python. Just like a string, integer, or float, a class is essentially a custom type that has some special properties. Well, I would say if it's custom, it's not like a string, integer, or float, which are built-in types. But I'll move on from that quibble. An object is an instance of a class type. In this example, health is an instance of an integer type. Health is an instance of an integer type. Okay. In object-oriented programming, we create special types called classes, and each instance is a class of an object. How do I create a class? In Python, you just need to use the class keyword, and you can set custom properties using in the following way. So let's do some typing. Class soldier health equals 5. So we now have a class soldier, and a part of that soldier is a health variable with the value of 5. Then to create an instance of soldier, we simply call the class. Notice that a class isn't a function. It doesn't take input parameters directly. Unless you have an init method, but I assume we'll get to that later. First soldier equals soldier, print soldier.health prints 5. Okay. Assignment. Create a class wall on line 1. So let's review, create a class wall on line 1. Let's review the syntax for creating a class. We type class, and then the name of the class, which here is wall, and a colon, then onto a new line, and it auto-indented for us. It should have a property called armor that is initialized to 10, and height that starts at 5. We'll run this. Yeah, it prints those values. Looks good. So there you have it, your first class. Methods. After the next exercise, you might be wondering why classes are useful. They seem like dictionaries, but worse. What makes classes really cool is that they allow us to define custom methods on them. A method is a function that is associated with a class, and it has access to all the properties of the object. A result of this is that in classes, we can have data and the methods that manipulate the data in the same place, which really helps for organization. And that ties into dry, don't repeat yourself. So we have class soldier health equal 5, def take damage of self comma damage, and self.health minus equals damage. If you remember from the previous course, it'll be in the playlist. Minus equal is a way of saying self.health equals self.health minus damage. Soldier 1 equals a soldier, soldier 1.take damage 2, soldier 1.health, and it prints 3. That all makes sense, right? The special self value. As you can see, methods are nested within the class declaration. Methods always take a special parameter as their first argument called self. The self variable is a reference to the object itself, so by using it, you can read and update properties of the object. Notice that methods are called directly on an object using the dot operator. Object.method. I feel like that should say instance.method instead of object.method. Right? Because it's the instance that you typically call the method on. Although if it's a class method, then you would call it on the class. I don't know. Assignment. Add a fortify message to your wall class. It should double the current armor property. Oh, that's useful. So let's look back again to the syntax. We have, it looks like a function definition, but because it's inside of a class, that's what makes it a method. Def take, what am I supposed to call this? Add a fortify method, fortify, def fortify of self. Because remember, methods in classes always take a self argument first, and then the instruction says it should double the current armor property. So we can say self.armor times equals 2. Let's see if that works. Yes, it does. Cool. Methods can return values. If a normal function doesn't return anything, it's typically not a very useful function. Methods often don't return anything explicitly because they often mutate the properties of the object instead. that's side effects. And the whole idea with functional programming is to avoid side effects. Whereas with object oriented programming, you have the methods, and the methods have side effects on the data of the instance of the class. So it's a different approach. That's exactly what we did in the last assignment. However, they can return values as well. Class soldier armor equal 2, num weapons equal 2. Def get speed of self, speed equal 10, speed minus equals self.armor, speed minus equals self.num weapons, return speed, soldier 1 equals soldier, print soldier 1.get speed, print 6. And let's keep track of those numbers. We subtract 2 for self.armor, and we subtract 2 for number of weapons, and so it gets it down to 6. So that makes sense. Now we have a comment. Eli says, saying object instead of instance is less confusing in Python because the only things that are called objects in an OOP sense are instances of classes versus JavaScript where everything is an object. And then Eli says, I gotta go to sleep, talk to you later. Okay, thanks for that comment. Have a good one. Was I mixed up over here? I said object.method. I guess it's okay to say object.method. Apologies for mixing that one up before. Okay. Coming back to this one, we have assignment, add a getCost method to your wall class. The cost of a wall is a function of the wall's height and armor. So we need to get cost, so we're going to return the result of a calculation. And that calculation is simply self.armor times self.height. Very good. Methods versus functions. Okay. What is a function? A function is a piece of code that is called by a name. It can be passed to data to operate on via parameters, and can optionally return data. All data that is passed to a function is explicitly passed through parameters. What is a method? A method is a piece of code that is called by a name that is associated with an object. Methods and functions are similar but have two key differences. A method is implicitly passed the object on which it was called. In other words, you won't see all the inputs in the parameter list. Instead, you see object.function.method name. A method is able to operate on data that is contained within the class. In other words, you won't see all the outputs in the return statement. The OOP debate. Because functions are more explicit, some developers argue that functional programming is better than object-oriented programming. In reality, neither paradigm is better, and the best developers learn and understand both styles and use them as they see fit. For example, while methods are more implicit and often make code more difficult to read, they also make it easier to group a program's data and behavior together in one place, which can lead to a code base that's more organized. And the question is, which operates within the scope of a class? That is a method. On to the next. Which is more explicit in terms of inputs and outputs? That is a function. Moving onwards. Constructors or initializers. It's quite rare in the real world to see a class that defines properties in the same way we've been doing it. Class, soldier, armor equal to, num weapons equal to. It's much more practical to use a constructor. In Python, the constructor is the init method, and it is called when a new object is created. So with a constructor, the code would look like this. Class soldier def init of self, self.armor equal to self.number of weapons equal to. However, because the constructor is a method, we can now make the starting armor and number of weapons configurable with some parameters. Class soldier def init self armor number of weapons, self.armor equals armor, self.number of weapons equals number of weapons. Now there's something worth mentioning here, that this armor goes along with this armor, while this armor belongs to the class. I think that could potentially be confusing if you're not used to this kind of notation. Soldier equals soldier of 5, 10. Print soldier.armor prints 5. Print soldier.numWeapons prints 10. So let's trace the path of where this 5 went. It got fed into the soldier and made its way to the constructor method, which in Python is this underscore underscore init underscore underscore. So there's the 5 being armored there. And then we tell the class that self.armor is equal to the value of armor that got passed in to the constructor. So hopefully that makes sense there. Assignment. Add a constructor to our wall class. It should take depth, height, and width as parameters. And set them as properties. It should also compute an additional property called volume. Volume is the width times height times depth. So we add a constructor to the wall class. Let's look again at what constructors look like. It's def dunder init. Dunder is for double underscore. Self, comma, stuff. And what is the stuff going to be? It should take depth. I'll copy paste it. Depth, comma, height, comma, width. Width as parameters. It should also compute an additional property called volume. And it looks like it should save that volume. Let's do it this way. Volume equals depth times width times height. Except I want it to be in order because I'm picky that way. So the thing to notice here is that this volume, which is a normal type variable, is separate from the self.volume, which is belonging to the class. Okay, let's test this. What did I do? Invalid syntax. I bet I forgot a colon. Yep. Now what? Indentation error. Expected an indented block. Oh, I forgot to indent. I guess I was talking too much and not paying enough attention to my code. Oh, it wants me to save all of these as attributes. Okay. Self.depth equals depth. Self.height equals height. Self.width equals width. Now let's try it. Okay, it runs all right. Should do good. Excellent. Constructor quiz. In Python, what is the name of the constructor method? It is dunder init dunder. Multiple objects. If a class is basically just a type, then an object is basically just a value. You'll often hear that an object is an instance of a class. Let's look at what that word means. In object-oriented programming, an instance is a concrete occurrence of any object. Instance is synonymous with object as they are each a particular value. Instance emphasizes a distinct identity of the object. The creation of an instance is called instantiation. So I was maybe trying to be too pedantic when I said, oh, we have to call it instance. We can't call it an object. But it says here that instance is synonymous with object. So for our wall class, I can create 3 separate instances of the class. In other words, I'll create 3 separate objects. South wall equals wall of 1, 2, 3. North wall equals wall of 4, 5, 6. And east wall, we're switching it around with wall of 9, 8, 7. What is happening next? Height equal 3, width equal 4, depth equal 5. In the example above, wall and integer are types, and each variable is an instance of one of those types. Oh, okay. So just making the course is just making the point that south wall is an instance of wall, whereas height is an instance of integer. Although it looks a little different because we didn't actually type integer, we just wrote the literal value. But it works out the same way. They're both an instance of one of those types. Okay, assignment. Take a look at the brawler class and the fight function provided. So we have class brawler, def init self speed strength name, self.speed equals speed, self.strength equals strength, self.power equals speed times strength, self.name equals name. Def fight, F1 and F2. And in this fight of F1 and F2, I guess F is the variable we're using for a brawler. Oh, F for fighter. That must be F for fighter. That makes sense. If F1.power greater than F2.power, print F1.name wins with F1.power power over F2.name's F2.power. Else, if F1.power less than, this looks like an error. This has got to be F2.name wins with F2.power. I'm not supposed to change below this line, I think. Yeah. It's a tie with both finished at F1.power. Well, if I undo, it undoes all of the code. That's interesting. So we're gonna practice creating 4 new brawlers. So I'm gonna use their names for their variable names. Aragorn equals brawler of speed 4, strength 4, named Aragorn. Gimli, I'm enjoying the Lord of the Rings names here, is a brawler with 2, 7. Gimli. Legolas equals brawler of 2 of, oh wow, 7 speed and 7 strength. Very strong. And Frodo, oh poor Frodo. 3, 2, Frodo. Then call fight twice. The first fight should be Aragorn versus Gimli. So we call fight of Aragorn and Gimli. And we call fight with Legolas and Frodo. So it actually doesn't matter that this code is wrong, but I'm still going to take a screenshot of it and maybe make a point, maybe mention it later. Okay, let's keep going a little bit longer. Objects quiz. A blank is an instance of a blank. An object is an instance of a class. Archers. Assignment. Complete the archer class. Constructor. So how do we make a constructor? Again, we start with def double underscore init and double underscore. Then it tells us it should take the following parameters in order. We start with self because methods always take self as the first argument. Num with arrows, health, and name. Then we do the getShot method. Create a method called getShot. So def getShot. That doesn't take any parameters, except that it does take the self parameter. If the current archer has health left, I should assign the variables. I think they're called attributes. Anyway, self.num arrows equals num arrows from the constructor, and self.health equals health from the constructor, and self.name equals name. Okay, get shot of self. If the current Arthur has health left, if self.health greater than 0, then it removes 1 health from the current archer. So self.health minus equals 1. Then looks like we do this on a new conditional. If self.health equals 0, it prints print f string with quote braces is dead, where braces is the archer's name. So we have self.name. What happens if we run this? Whoa, it's going slow. I haven't seen that before. Let's cancel. Shoot method. Create create a method called shoot that takes a target archer as an input. Def shoot self archer. Now this is interesting because we're passing another archer object into the archer method. If self.num arrow, I made a mistake here. This should be num arrows. If self.num errors equals 0, print f quote self.name can't shoot. Otherwise, so that's an else statement. Remove an arrow from the shooter. So self.num arrows minus equals 1. And print f quote 1 shoots 2. functions 2, where I'm going to call this self. I'm going to call that other archer. Self.name shoots other archer.name. Let's run this. Something is happening. Why is it printing in red? That's confusing. Let's refresh the page. Now it's not printing in red anymore. This is going to take a while. Well, let's go to the break screen while this code is trying to run. Okay, let's get back to it. I canceled code execution because it was going on for quite a while. And turns out the problem is I didn't read the instructions. The instructions say, next call the target's get shot method. So here we have to say other archer. Where's my, there it goes. Dot get shot. Sure. Get shot. Now let's run this and see if it doesn't do an infinite loop thing. It's still going for a really long time. Let me read through all the instructions. Create a get shot create a method called get shot that doesn't take any parameters. Get shot of self. If the archer has health left, if self.health equals 0, self.health minus equals 1, then if the archer's health is 0, it prints the string archer is dead, where braces is the archer's name. Next, shoot method. Create a method called shoot. If the archer has no errors left, raise the exception. Oh, raise the exception. You really have to know the stuff from the previous. So how do we raise an exception? We don't print it. We'll just raise a general exception. Okay, now let's try it. Invalid syntax. I guess you can't have F. Or is it like this to raise an exception? Still running forever. Raise the exception. Brace can't shoot. Bard can't shoot. It's not raising the exception for me. Oh, I didn't actually call it. There we go. There were a lot of details in that one. I kind of got lost. So let's go through the code and talk about what all happened in it. Let's actually submit and make sure that this is right. Yeah. Class archer def init of self num arrows health name. Self.number of arrows equals number of arrows. Self.health equals health. Self.name equals name. So it's a constructor like we saw before. Then we have defined get shot of self. If self.health is greater than 0, lose 1 health. And yeah, because you got shot. And if self.health equals 0, then print self.name is dead. Then define shoot. If self.number of arrows equals 0, raise exception, self.name can't shoot. Else, decrement the number of arrows, print self.name shoots other archer.name, and other archer.getShot. And the parentheses are important because you're calling the method. Class variables versus instance variables. So far, we've worked with both class variables and instance variables, but we haven't talked about the difference yet. We haven't really talked about the difference yet. Instance variables. Instance variables vary from object to object and are declared in the constructor. Def init of self, class wall, self.height equals 10. South wall equals wall, south wall.height equals 20. Only updates this instance of a wall. Print south wall.height. North wall equals wall. Print north wall.height prints 10. So even though the height instance variable on south wall got changed to 20, when we look at north wall still has a height of 10. Now class variables. Class variables remain the same between instances of the same class and are declared at the top level of a class definition. This time, height is a class variable because it's declared at the top here. And if we say south wall equals wall, print south wall.height prints 10. Now if we say wall.height equals 20, it updates all instances of a wall. Print south wall.height prints 20. I wonder if let me try something. Class wall self.height equals 10. Let's say wall.height equals 20. W equals wall. Print w.height. I assume this will also give 20. Error. Self is not defined. Oops, I was thinking of, okay. When you do an instance variable, you need self.height, but when you do a class variable, you just need height. Let's try this again. Yeah, 20 is the height that this new wall gets. Okay, let's reset the code, and let's look at our assignment. Which should I use? Generally speaking, stay away from class variables. Just like global variables, class variables are usually a bad idea because they make it hard to keep track of which parts of your program are making data updates. However, it is important to understand how they work because you may see them out in the wild. Assignment. Due to our terrible class design, some lazy code owned by a different developer team is causing some bugs in our code. We can fix it using instance variables instead of class variables. In the main function that our team isn't responsible for, yeah, I can't change the main function, I guess. A line like dragon.element equal fire should have no effect on our existing dragon instances. We don't like near global variables. We want our users to specify each dragon's element in the constructor. Update the dragon class. Remove the element class variable and instead use an instance variable that's configured via the constructor. So we take away element ice init. Why do we have a return value on init? I guess because I haven't explained paths yet. Okay. Self.element equals element. Now what do they do? When we say that dragon.element equal fire, that should error out, shouldn't it? Oh, it will still have, okay. That doesn't matter. Fire Dragon does 300 damage, Ice Dragon does 150 damage. Poor Ice Dragon, not as powerful. Encapsulation. Oh, that was the end of that chapter. Yay! I'll take a drink of water. Maybe that's enough for tonight. It's almost 10 o'clock. Yeah, we can make it a short stream tonight. No need to really push on. Thanks everyone for hanging around. It's been a good night. Let's see, is there anyone to raid? Not really. But let me check one more time. Why am I logged out again? That's annoying. I'm not going to do this now. We're just going to stop the stream. Thanks, viewers, for hanging out, and have a good one.